Hello everyone. So today we are going to solve another interesting problem number 647 palindromic substring. And this problem is about we have been given one string S and they are asking us to return the number of palindromic substrings in it. So a palindrome is basically a string that reads same from forward or backward. Meaning basically, so let's say if we have race car or some like ABBA, then it reads from left the same and from right the same. So that is what they want by palindrome. And substring basically the continuous subsequence of characters. So that is basically ABB is a substring, BBA is another substring, but A um, and A, this is a subsequence. So that we need to remember between substring and subsequence. And it's a fairly straightforward problem. So they are asking us to find the number of palindromic substrings in a given string. So what we can do is we can first approach would be the brute force approach, in which we can for any position I, we can look for its neighboring substrings, and that we can get by traversing two for loops together. And the every substring that we have, then we can check whether that substring is palindrome or not, and that will eventually be of time complexity O of n squared to creating substrings, and O of n for checking whether a substring is palindrome or not. So that way, this brute force approach would be O of n cubic time complexity. So now we can move to next approach, because can we do better? The question remains the same. So yes, we can do better in the separate second approach that we have. So in the second approach, we can use one DP tabulation to find whether our given substring that we are traversing. So suppose we have this substring ABBA, and we are traversing the characters from left and from right. And as we are traversing down, we can check whether the substring from index I to j is palindromic or not by making a TP table for the initial string that we have in the form of table, and then we can check that whether this is a palindrome or not. So that way we can do it in time complexity of O of n square. So that is definitely a leap from O of n cube. But in doing this, so we have increased the time complexity from O of 1 to O of n square. So now the again question is, can we do better in this scenario? So my answer would be yes, I can do better. So what we can do is we can enumerate, basically we can count every substring one by one and check around the midpoint of every substrings that whether this substring is palindrome or not. So what we'll do is for any position, we'll will check up to the position of, so if this is of size n, then what we'll do is we'll to check for any position, we'll keep two pointers left and right from where our we are, and we'll spread these across opposite side, and we'll check the characters that we have in by expanding this region. And if the characters matches, then we'll increase the count of one variable to uh, give us the number of count of palindrome that we have. And by expanding the region and checking whether the characters that we are seeing are same, or not, we can say that we have found a palindromic substring or not. That way we'll be doing this, solving this problem in time complexity of O of n square with a space complexity of O of just 1. And for to handle the edge cases, to handle the cases better, what we'll do is we'll expand the window of n size to another virtual window of size n. So if I'm at this location, then from here I want to expand the windows in two directions. So if I want to expand it on the right hand side, then I need one another region where I could check whether the substring that I am getting across this midpoint are valid or not. So that would essentially not be seen over here, but uh, to handle the ranges, this is a technique that I use to solve this problem. So now let me get into the coding part for this and show you that this is the best solution for this problem, best optimized solution. So what we'll do is I'm going to need this last approach that I discussed with you. So we'll keep one count variable for counting our palindromes and one n variable for our length of the substrings that we have. And now for any position in the substring in the string where we are, we'll keep two pointers at the mid of that location. So that is I have a 2, and we'll place the right pointer ahead of the left by 1. And now we'll check until we have exhausted both the left and right pointers in their region on left and right hand side, and with the characters for checking the substrings that whether they are palindrome or not. So if the characters are matching, then only we'll go inside and increment our count variable by 1, because we have seen in this region that our substring is palindrome, and we'll keep expanding our substrings in both left and right hand side by decrementing the left pointer and incrementing the right pointer. So, and in the end, we'll just return the count, because that has the total number of palindromic substring that we have. And now let's run this solution and see how it performs. So for our ABBA, the number of substrings would be 6. So that we should be adding. And the number of palindromic substring that we have over here. It's saying not a valid value of type string. As example, okay, so they want us in this form ABBA. So here the total number of substring for ABBA. So the substrings for ABB and A would be basically n into n plus 1 divided by 2. So that is nothing but 4 into 5 by 2, which is 10. And out of these, the palindromic substrings are basically A, B, and another B, because single characters, if you read from left and from right, from forward or backward, they read the same. So A, B, B, individual A, these are all palindromic, and then BB, and then at the last ABBA. This is palindromic substring. So total the palindromic substring for ABB and A is 6. So that is what we will be getting. Okay, so now that's the ideal solution what we need to get, and now let's submit our code and see how it performs for all the test cases. So it has been accepted and it's pretty fast and it's covers all the test cases. So that's how you solve this problem. And please let me know if you have any more problem that you want me to solve, and please like and subscribe to the channel. It motivates me in bringing such more awesome content for you guys. And thank you. Have a nice day. I will come back tomorrow with another algorithmic approach to solve these problems. Thank you and have a nice day.